1991. Kuwait, Operation Desert Storm. Iraqi tank columns are moving through the desert night. They never see what hits them. 8 Apache helicopters, flying nap of the earth, below radar coverage, in complete darkness. In 17 minutes, they destroy 32 tanks, 10 armored vehicles, and 16 artillery pieces. 0 Apache losses. The crews called it a turkey shoot. The AH-64 Apache wasn't just a helicopter. It was a flying weapons system engineered to dominate the battlefield. Day, night, in any weather, against any ground target. This is the story of how engineers built the most lethal attack helicopter ever to fly. The Apache was born from failure. In Vietnam, American forces learned a brutal lesson. Helicopters are vulnerable, slow, loud, easy targets for ground fire. The Army wanted something different, not just a helicopter that carried weapons, a weapons system that happened to fly. Hughes Helicopters won the contract in 1976. Their design brief was uncompromising. The Apache had to survive hits from 23mm cannon fire. It had to fly in zero visibility. It had to kill tanks, the main Soviet threat in Europe, at ranges beyond their ability to fire back. Every single design decision flowed from those 3 requirements: survivability, visibility, lethality, in that order. The Apache's rotor system is not conventional. Most helicopters use aluminum rotor blades. Light, efficient, but catastrophically vulnerable to battle damage. A single bullet can shatter an aluminum blade. The Apache uses composite blades, fiberglass and carbon fiber construction. Each blade can absorb multiple hits from 23mm rounds and continue flying. The 4-blade main rotor is specifically designed for nap-of-the-earth flying, the technique of hugging terrain contours to avoid radar detection. Quick direction changes, rapid altitude shifts, aggressive maneuvering that would tear apart a conventional rotor system. The tail rotor is equally engineered. 4 blades in an asymmetric configuration, 2 pairs set at different angles. This reduces the distinctive whop-whop sound signature, making the Apache harder to hear at distance. And if the tail rotor is destroyed entirely, the Apache can still be controlled. Engine torque management allows limited flight even with complete tail rotor failure. Engineered to keep flying, no matter what. The Apache carries 3 weapons systems simultaneously. First, the M2-30 chain gun, mounted under the nose. 30mm rounds, 625 rounds per minute. The gun is slave to the gunner's helmet. Wherever the gunner looks, the cannon points. Turn your head left, the gun turns left. Look at a target, the gun is already aimed. Second, Hellfire missiles, up to 16 AGM-114 Hellfire anti-tank missiles on 4 weapons pylons. Laser-guided, radar-guided, millimeter-wave guided, meaning they can lock onto a target and hit it with no further input from the crew. Fire and forget. At maximum range, 4 kilometers, a tank crew has no warning. The missile travels faster than the speed of sound. By the time they hear it, it has already hit. Third, unguided rockets, Hydra 70 rocket pods, 76 rockets per full load, for area suppression, infantry positions, light vehicles. The Apache doesn't choose between precision and firepower. It carries both. Weapons are only as good as the eyes that aim them. The Apache's targeting system is called TADS, Target Acquisition and Designation System, combined with PNVS, Pilot Night Vision System. TADS sits in the nose of the aircraft, a rotating turret containing a forward-looking infrared sensor, a television camera, a laser rangefinder, and a laser designator. It can detect a human-sized target at 3 kilometers in complete darkness. PNVS feeds thermal imagery directly into the pilot's helmet-mounted display. The pilot doesn't look through a cockpit window. They look through a sensor mounted on the nose of the aircraft. Turn your head, the sensor turns with you. The entire world is rendered in thermal infrared, projected onto one eye. At night, in a sandstorm and smoke, the Apache sees everything. The crews in Desert Storm described flying Apache missions at night as seeing the world in green fire, every vehicle, every soldier, every gun position, glowing clearly against the cold desert ground. The Apache was designed to be hit and keep fighting. The crew sits in tandem, pilot behind and above, gunner in front below. Both seats are surrounded by boron carbide ceramic armor panels, capable of stopping 23mm rounds at close range. The cockpit itself is designed to protect each crew member independently. If the gunner's position is destroyed, the pilot can still fly and fight. If the pilot is incapacitated, the gunner has basic flight controls. Critical systems are redundant and separated. Hydraulic lines run on opposite sides of the fuselage. A single hit cannot disable both. The two General Electric engines are separated by a firewall. One engine can be destroyed while the other keeps the aircraft flying. The fuel system is self-sealing. Bullets pass through. The tanks close around the puncture. The Apache wasn't designed to avoid being hit. It was designed to survive it. The AH-64 Apache has been in continuous service since 1986. 40 years, every major conflict the United States has fought. Panama, Gulf War, Somalia, Bosnia, Kosovo, Afghanistan, Iraq. It has evolved constantly. The original AH-64A became the AH-64D Longbow, adding a millimeter wave radar dome above the rotor hub, allowing the Apache to detect and prioritize 256 targets simultaneously while hiding behind a tree line. The current AH-64E Guardian adds even more: digital communications, improved engines, the ability to control unmanned drones directly from the cockpit, using the Apache as a command node for an entire swarm of surveillance aircraft. 40 years of continuous production, continuous improvement. 17 nations operate it today. The engineers who designed the Apache in the 1970s built something with enough fundamental capability to remain relevant half a century later. That is the ultimate measure of engineering excellence. Not how good it was when it was built, how long it stayed the best,